I'm Mason, and in this video I'm going to show you how I made the oil gun, then how I tested the spraying, and then I will talk about the electronics and the application that I have made to run the whole thing smoother and for automation later. I'm going to do a more detailed version with more voiceover and a total documentary about the whole thing. This is going to be a long one still, so enjoy. Without further ado, let's crash straight into it. So here I'm just welding up the body first. That I didn't really record that, but I have cut out the pieces from a steel sheet, and then I have rolled them into tubular things, and then I welded them together. Also the cone. Now I'm drilling out the holes for the nuts or bolts, more accurately. These are going to be the thermovalves for the thermocouples. Unfortunately, I have not taken one thing into account, that I will need to drill the whole thing, so I had to cut the whole body again up into two pieces. Then I have drilled a hole, two holes on the body on both sides for the bolts, and I'm just drilling the holes. Then I'm just going to weld on nuts on both sides 180 degrees apart, and then I'm just going to weld the body up. Now I'm welding on the nuts, and then I have screwed in the nut or one bolt in. Then I broke off the cap, so I had to drill the whole thing out. With long struggle, I've been able to take it apart, take it out, or drill out the middle. Then I have screwed in like a metal screw, ran it back and forth. Then I did M6 thread cutter through the whole thing with the drill. I have sucked with this for a long time. I was kind of angry and pissed off, but then I have finally got the piece out, and then I was able to screw in the bolt, welded the whole thing around. I mean, I did have the nut welded on, but I finished the welding here. Then I switched the whole thing up, and then started to weld the other part around, the other nut, onto the body. This is necessary because the steel was made from sheet, and it is not really good for having the thread, so you can't really cut a long thread into it. Here I'm just drilling the hole into the inner tube, which you have been able to see in the beginning, and that is basically there to carry the oil forward. I'm just drilling the hole from the top, and then I'm cutting M6 thread to it. Then I realized that I will need to cut the whole body up again, so I will need to adjust the whole thing and weld on the nut into the inner body as well, or the inner tube, because it was not thick enough for the thread. Here I'm just ticking it with the TIG welder, tacking it with the TIG welder. I am going to weld the whole thing around, and then here I have welded it all around. I have already started to place the thing. Then I tapped onto it with the hammer so to straighten it out. Then I tigged it again. It was kind of bent, and you will be able to later see that the whole thing is just bent all over the place, because I haven't really thought. Some things came up. This is only version 1, so that is why I said it's going to be like kind of shitty. So yeah, then I have welded around at the body. And also at the back. Here is just finishing the weld around it. I've also already applied the air tube. I have thought of adding a coil over the body because you need to heat up the air, the atomization air, so that the oil will light, because the oil needs like 180 degrees Celsius. So I thought of just going to add a coil over the body, but to insulate it from the steel casing would need to add a layer of clay. The white mesh is glass fiber. I am going to apply the clay on it and then wait till it dries. Here you can see the blower that I will use. So this is the theory behind the whole thing. It is not going to be nice or fancy, but going quickly over it. Here we have compressed air and we are going to have the oil coming from here. The oil is going to exit here with the compressed air around it coming in like so. Basically how the thing works is that here this distance is really small. It's like 1 millimeters. What that does is that we push the oil in a constant amount, and the constant amount of air is pushed in. This is compressed air, around 3 bars ish. As it is expanding to atmospheric pressure, it speeds up. 1 second, because we reduce the diameter, it also speeds up. So here at the exit, this is why we want a small gap, so that we have a quite large amount of velocity of this compressed air that will give us shearing force, which is basically shearing happens when you have two forces acting in parallel. This is very basic. So this is going to create a shearing force between the oil droplets, and what that is going to do is that it is going to shear these little droplets apart, creating more fine from big droplets into smaller droplets, basically from a liquid. This is like liquid, this is like a mist. We want this mist because what mist does is that it will increase the A, which is the surface area of the whole thing, that on these little kind of microscopic bits, as you have like this little droplet, the higher the surface area, the more it will be volatile. And with like diesel, which is kind of not volatile in itself, but when you break it up into fine particles, it will give us more surface area, decreasing the required temperature that the flame needs to have so that the particle will burn. On the edge of this droplet, the combustion will start and giving us a nice and steady flame here. Another thing that we want and why we need the blower is that the compressed air is not going to amount enough air to completely burn the oil, because I don't know if you did know it or not, but 1 milliliter of oil, let's call it diesel or veggie oil, roughly needs 4.2 liters of air. 4.2 liters of air. 4.2. That's a fuck ton. And if we are pumping through 1 mil per sec, which is not that much, we need 4.2 liters of air per second. That's a lot. That's a lot of air. And partly we can provide like 20% of the total combustion air with the compressed air, but 80% is still missing, which we will solve in a second stage. How I'm just going to do it is we're going to have the ignition here and the pilot here at a 90 degrees angle, which you don't see just yet. It will be in the next video. I have already done it. You can look back up the live stream if you really want to, but for now we will go with this. And spoiler alert, we will not be able to use the heating coil because it doesn't provide us enough heat. So back to the point that why we need the blower. Why we need the blower is because we do not have enough air, and how we are going to do it is that we are going to supply the air, this 80% of the whole air from here through with a blower. It doesn't need too much pressure, and this is why only 20% of the whole thing requires compressed air, because not effective to use this because it would require a very big compressor relative to this, when like a cheap blower can be used for 80%. So this like sizes down the equipment as well with this option. We provide the air here, which is going to come around the whole thing and going to go around here and here and here. And what we are going to do is that as we supply the air and the first, when we start the whole thing up, we are not going to provide only just air for the gas. This is the pilot, which provides us gas, which is propane, butane, and air plus this gas on the ignition spark plug going to create us a flame. That flame is going to be really hot enough so that when we spray our first oil in, it will light, but it will not burn clean again, just 20%. This is where the air comes in into this secondary stage, which is here, when it is mixing with the this is what they call a fuel-rich zone, when you have more fuel than oxygen to combust stoichiometrically and cleanly. So here there is like a yellow sooty sheet flame here, but as we provide this lot of air to it, it will combust clean and create us a big flame here, as well as, I mean, it will not be red, but actually blue because of the clean combustion. And this is what we are going to do. This is why we need the second blower, and this is why I will use it. Here you can see I have old some Soviet Barkas, or I don't know what, air blower. It is like a beat shit blower. Impeller is still fine, the motor is just too weak. It was just barely puffing any air out, and I'm just going to swap out the motor inside that and replace the old bit to shit little DC motor with this more powerful one. This little sketch that I have made is a gray, you probably can't see it on the video, but it is a drilling pilot that I use here to drill the holes onto the impeller, so that the screw places that I will screw the impeller onto the new motor have the new motor screw placement properly around the circumference and as well as the radius. It got a bit I had to wiggle a bit with one, but it was pretty cool and pretty accurate. Here you can see me removing the motor, these legs. I have drilled and now chiseling them away. They come loose very easily. I mean, the second one took more because I didn't really throw. Then I put this 3D printed aligning piece in, which I will use later. Now I'm just making a disc that I will put over it, so that I can weld the little legs to the whole thing. I'm cutting it from sheet 1mm steel. I'm cutting the circle around with the standing scissor. Then I'm just going to drill the inside hole. Then I'm going to mark all over the circumference of the inner diameter. It will take a long fucking time. This took like, I don't know, 60-70 pointing hits, and then I had to drill them all out. And you can see that even here with the speed through it takes like quite a long time, and you can't even see the whole thing I have cut here. It took like a long time till I drilled out all of them. And I have figured now out that I can't really cut them out, so I had to like go back in with the drill and had to like manually like wiggle around the drilling bit so it cuts the steel between the holes, and slowly doing that takes a long time as well. And then finally at the end, when it all came loose, I just take a plier and then just take it out, chuck it into the vise, then use like a little bit to clean up the edges around the circle so that it fits nicely. into the blower casing, onto the blower casing, then cleaning off the edge here with the little hand scissor. Now assembling the whole thing with this aligner, putting in the whole thing, putting in the motor, then putting on the legs that I have straightened out with the hammer, then marking the whole thing out. Then I'm cutting out the holes for the legs. Thank God this is made from PLA, so it breaks off like relatively easily. The unfortunate thing is that if I made this from like veggie, I would have like struggled more to cut it out, but PLA just broke off really easily, which is kind of sad that this is just this weak. So marking it around on the body, and I'm just going to MIG weld it, tacking the disc around a few places. And then I'm just going to MIG weld the legs onto the body as well. Or I didn't want to really weld it a lot, not to melt the insides of the motor, not to ruin the aligner. So I just tagged it a few places, and then I have given it a bit more care later on. But around the disc, later on, and it will not be in the video, but I used some silicone to seal it out so it doesn't leak. And then I am just going to hook up the motor, so to see if the whole thing is working or not. It works. Now I'm just going to drill a few holes around, I think 3 on the radius, so that I can screw the motor standing legs, cutting the M6 thread into them so that I can secure them, then screwing the screws in, and then trying it out again. The blower is working nice. I have used 12 volts. Here you can see like a veggie test that I pump the air up. I will even run this later on with maybe a bit more voltage, at like 13 volts or 14 volts. It produces kind of a lot of air. Here there is like a test of the oil gun sprays into the ether. This is a bit tuck in the beginning, but I have realized that if I'm just going to crack more air, then I'm going to be able to use it. But as you can see, it is producing a fine mist, which is kind of cool as well as very useful. I have made the whole thing work. First things first, talk about what is what. This is this little shit is a lever shifter. This is the R32, which is a ESP based. It's like the Uno. This is the Arduino Uno, but this is cooler, but has the weakness of not being able to operate fucking relays at 5 volts because it doesn't produce enough amperage, or I mean it doesn't provide enough amperage. So the either SSR or mechanical relays, they won't open. The LEDs will light up, but they won't open. So therefore the SSR, so the solid state relay or the mechanical relay, need to be driven from the Uno. But in order for us to be able to know that if the relay is on or off, we will have to send the data from the Uno to the ESP32, and therefore we need the level shifter basically, so that this shit head has the PID, now the bang bang, which means just fixed time. Let's say 2 seconds off, 3 seconds or 2 seconds on, 3 seconds off. It controls the relay, which controls the coil on the oil heating gun, and that's going to heat up the air and with it the whole gun. And we are going to be able to test in like three runs with three different proportions. So think it as like a PWM, which is like adjusted in like percentage, which means that it opens so fast that it basically like halves, or you can 80%. You basically like you can cut down the power on it by fast, like very rapidly opening and closing the relay. And what we do here is that we are going to test with three settings, probably like 25%, 50%, or like 20%, 35%, 50%, maybe I don't know the exact numbers. This is more of a conservative run first, so that we know the thermal, basically how the gun behaves in terms of like heating up, how it conducts the heat, how it cools down, all this stuff, how hot the air gets. We will not test with the oil first, because I don't want to like, I mean, initially we will say I will start the oil to adjust the air so that the air will like atomize it fine. Then I close the oil, and then I will just test it with basically that, so it heats up nicely and evenly. That way the air is most of the cooling power. The oil is very negligible. I don't even think that it is above like 5 to 10% of the whole cooling, or the whole thermal like heat loss basically. So the air is going to be, and the outside surface area that's going to radiate the heat away, that's going to be the main loss of heat. So that is already done. So what we are going to do is that we are going to collect data, and what this whole bunch of wires and all this shit is there for. Maybe I'm going to set it up for you. I'm going to power the laptop if it is like wanting to work. Okay, it turns on. Let's go. The boards should, oh, the boards are not connected, so be right back. So yeah, the two boards are live, and if we were to go into this, the Arduino or the ESP32 says the Uno says that the relay is on and off. As you can see on the light there, it is turning off, or I mean on now, off, on. Basically it says this. We send it the data, as well as you don't see it probably, but we have two MUX 6675 thermocouple boards here that have the thermocouples and there, and I believe somewhere along there. So those are in this chaos, whatever. They measure the temp, and the ESP sends both the temps, which are going to be there for the oil and the air of the gun, with the relay state. It sends through here via Wi-Fi to MATLAB, which is going to be, I'm just going to start this. This is basically an app that I made and have been debugging this whole fucking shit for now, but you can see here pressure is not live. We don't have a pressure sensor there. That's why it is not like showing anything or working. We can see the temperature changing over time. This is going to be averaging nicely over, just like this. It's going to go like up and down, and you will be able to see it around the temp. We will be able to average these readings out, and then we will be able to gather the data that we need from the tests. Basically, this is like a gauge that I can look at now, and this is going to be really good in that sense that when I close the app, I will be able to, basically it saves all the data that we have collected from the beginning of the launch or the start of the app, and then we are going to be able to put this data set into the MATLAB PID tuner, going to create a PID model for it, and going to test it out for basically the uninsulated, it's not here, but you will be able to see it, the uninsulated gun. And then if we have it, then we're going to run a few PIDs on it to test and tune it to the right temperature range, which is going to be around this. So the oil temperature is going to be like 120, 130 to like 160, and the air is probably above 180, which would be pretty good, around 200-ish, because that would be able to light up that temperature range. As I said, you can see that there is like a trend here that we can draw a line across here as well, around 29.9 or something like that. So yeah, that's it. That's it for now. I'm going to basically cut down what you're going to see. I'm going to box this whole thing up so that it won't be like this, like all over the place. I'm going to make it so that it is a bit more organized and it is enclosed so that we don't spray oil over it and all this shit. So yeah, this is what I meant under boxing, getting the things into place. I have a bit to do. In this episode we're going to test the relay. I'm going to bring you closer. This is the TOTAS assembled thing. If you really look through this jungle of cables, you can see the SP32 based R32 there. You can see the Uno here. You can see the relay here. Here is the snubber circuitry. Nothing is connected, as you can see, so before I touch anything and get electrocuted. So this is going to be then this is the live wire, this is the protective earth. In that lower one is the neutral. So the scrubber or snubber is basically connected in between the neutral, or the live wire and the neutral, parallel to the connected wire, which is this gray one. It goes through there underneath and comes here to the transformer primary. It transforms the 230, 240 down to 12 volts. It's going to create a big pool. I'm going to have to grab my power meter to see how much amperage I'm drawing through the line that's going to be connected there. Then I have already marked the live wire on this, as well as on this connector. We use like a phase pan, like so, that has a little LED or I don't know light in it. So if you plug it into the outlet, you can find the live wire, so you don't. You are not going to switch with the relay, because it is, if you don't know it, you need to switch the live wire with the relay, not the neutral, because it can lead to some problems, some safety problems. So that's why it is better to switch the live, and you need to find it, because in the wires it can be swapped up, even in the connector, and you can as well always like connect the connector up in two ways, so you get either the live or the neutral. So it's like a 50-50, and you don't want to risk anything. So this is a way better way. Okay, app is running, nothing is happening. I mean, we are getting the data from the temperature sensor, that's good. We are not getting any relay states readings, which is also great. I'm going to plug this in. Hopefully I'm not going to fuck myself up or anything like that. Just going to plug it in. We're getting the power, drawing 400 watts, 500 initially, 410, 500, it goes down to 400. 390, the relay states are coming through. We are drawing 476, 385. Yeah, 90, 970, or 470. Yeah, 465, 460, 370. Zeros. Let's go. We are getting new values. Okay, fine. It is working now. Fine. I don't even need to use the thermometer.